All right, so now we have in radians. What is this closest to? Which radian ratio that we know of for sine? If you don't want to think too much, pi, let's say. Isn't this bigger than pi? Right, so which one is this closer to? Pi or 2 pi? 2 pi is 24 pi, right?
Yeah.
So is it closer to 24 or 12?
It's right between.
Yeah, so what about 3 pi over 2? That's 270 degrees, right? So 3 pi over 2 is this rotation, right? 3 pi over 2. Okay, what would that be in base of 12? 3 pi over 2. Right, 18 pi over 12. So it's actually slightly past the 270 mark, right? Slightly past the 270 mark. So we can do this. Well, it's very close to 3 pi over 2. So 3 pi over 2, and I can see that it's going to be pi over 12, right? Do you guys remember the value of sine of 3 pi over 12 and cosine of 3 pi over 12? Actually, you don't even have to remember. You can visualize it.
Sine is -1, cosine is 0.
Okay, so let me write that. Using the sum formula, I get this. Sine, cosine, plus cosine of, and sine of. True? So sine of 3 pi over 2 represents, in the unit circle, we're talking about the y value right there. What's the y value right there in the intersection point? -1. So cosine of pi over 12, we still need to figure that out. What about what's the x value in that location? 0. True? So we only have to deal with this. So this is an example I gave you in class, how to deal with pi over 12. So pi, think of it as 4 pi minus 3 pi. Why 4 and 3? Do you guys remember? Why did? Yes, so we get that because 4 and 3 are factors of 12. That's why. Okay, so now it's cosine of, actually let me write this first, pi over 3 minus pi over 4. Cosine of pi over 3, cosine of pi over 4 plus sine of pi over 3, sine of pi over 4, right? So Tim, what's cosine of pi over 3? It's cosine of 60, so it's actually half. 45 is always root 2 over 2. Sine of pi over 3 is root 3 over 2, right? Cosine of 60. That's it. Base 4, it's root 2 plus root 6.